Algebra 2 students, today we're going to learn about some different counting principles. This is the number of or types of ways that you can count the number of ways that something can be done. The three principles we're going to talk about, number one is the multiplication counting principle, which says if event M can occur M ways and is followed by an event N that can occur N ways, then M and N can occur in M times N ways. So basically, when you have multiple events happening and one event does not affect the other, you just decide how many ways can I do each of these events separately and multiply them together. The second principle is permutations. This is when a group of objects or people are arranged in a certain order. And when we do permutation, we will be solving something like this, like permutation 5 choose 2. If you do this on your calculator, you're going to put 5 in your calculator. You're going to go to probability. You will choose the NPR button and then put in your 2. And for 5 choose 2, you should get 20 as your answer. The third principle we're going to talk about is combinations, and this is when a group is selected and order is not important. So if order is important, it's permutation. If order is not important, it is combination. And similar to permutations, we would do combination 5 choose 2. We're going to put a 5 in the calculator. We're going to go to probability and get our NCR button and plug in the 2. And this should give you a total of 10. So applying this with some different problems, here are different examples. The first question says, Carlos has homework in math, chemistry, and English. How many ways can he choose the order in which he does homework? So we could think of this as a multiplication counting principle. He has to do 3 things. He has to determine which homework will he do first. I'm sure he'd do math, but he would have 3 choices for his first event. His second event is what would he do second. He would have 2 choices left for that. And then what homework would he do last? He'd have 1 choice. I would multiply these together and we would get 6. In this case, order is important. We could have also done this by permutation. There's 3 subjects and I'm choosing 3 of them. And permutation 3 choose 3 is the same as 3 times 2 times 1, or 6. Those 3 would be math, chemistry, English, math, English, chemistry, chemistry, math, English, chemistry, English, math, or English, math, chemistry, English, chemistry, math. Those would be the 6 different ways. Next one says each question on a 5-question multiple choice quiz with choices A, B, C, D. How many different ways can the questions be answered? So once again, I've got 5 events. I have to answer question number 1. I could answer it 4 different ways. I could answer question 2 4 different ways. And question 3, and question 4, and question 5. And then I'm going to multiply these together. I'm going to take 4 to the 5th power, which gives me 1,024. So that is multiplication counting principle. The next question, how many ways can a teacher choose 6 students from a class of 25? So in this case, we're really only doing 1 event. We have 25 students, and he's picking a group of 6. This is a group. This is like a committee. Order's not important. It's just a group of 6. So this is simply a combination problem, and it would be combination 25, choose 6. So again, using my calculator, I'm going to put a 25 in. I'm going to go to probability, PRB. I'm going to choose combination, put 6 in. 25 combination 6 is 177,100 different ways to pick a group of 6 from 25 students. Next question, how many arrangements of the letters in the word drive? I could think of this as 5 events. The first thing I'd have to do is pick one of the 5 letters to start with. Once I pick that, I'd have 4 choices for the second letter, then 3, then 2, then 1, and I would multiply these together. Anytime the word is and, we're going to multiply. Order is definitely important here, so this is also permutation. 5, choose 5. Either way you do this, you would get a grand total of 120 different ways for the word drive. Choosing 3 classes from a list of 12 to schedule for first, second, and third hour. So now we're specifically talking about the different hours, so the order makes a difference. Because I could pick 3 of the same classes, but if I switch up when I take the class, it's different. Since order is important, this is a permutation, and have 12 classes, I'm choosing 3. I could also think of it as multiplication counting principle. I'd have 12 choices for the first hour class, then 11, and then 10. So it's 12, choose 3. So I'd go 12, I can go probability, choose permutation, and 12, choose 3 would be 1,320 different ways. All right, so then we got permutations. Permutations of just a simple word math. That means I'm putting 4 different things in order. I could think of this as 4 times 3 times 2 times 1, or permutation 4, choose 4, and this would be 24. The rest of these we have repetition. Repetition, which makes a difference here because in this case, I've got 2 C's, and I could switch these 2 C's around, and that would not change the arrangement of the letters or the word that is formed. So to do this, I've got 6 letters. So I'm going to do 6 factorial, which means 6 times 5 times 4 times 3 times 2 times 1. I'm going to divide by, since I have 2 C's, I'm going to divide by 2 factorial, which is 2 times 1. Those 2 times 1s would cancel, and I'm going to get 360. I could also, on my calculator, if you put a 6 in, go to probability, your factorial button is the 3rd in that list, and then divide by 2 factorial, and that still gives you the 360. For Alabama, there are 7 letters, so it's 7 factorial. If all of those letters would be different, that would be your answer, 7 factorial. But I've got repeats. I've got 4 A's, so I'm going to have to divide by 4 factorial. So on my calculator, 7, go to probability, choose factorial, divide by my 4 factorial, and I would get 210 different ways. For Papa, there are 4 letters, just like math, but I've got repeats. And in this case, I have 2 P's and I have 2 A's. So I'm going to multiply there on the bottom. When I do this on my calculator, I'm going to go 4 factorial. I'm going to divide by 2 factorial, and then divide again by 2 factorial. And this would give you a total of 6. Those 6 would be Papa. I could have this. I could have this. I could have it this way. And then I could start with the 2 A's and with the 2 P's. I could start with the 2 P's and with the 2 A's. Those would be the 6 different arrangements of the letters in the word Papa.